Math 1332, Summative 1 review. First question, write the Hindu Arabic numeral using Egyptian hieroglyphics. So here, this number here represents 70,000. This one represents 4,000. This is 500. So we want to look at the symbols. So we have a symbol for 10,000, which is kind of looks like a pointing finger. So I'm going to need 7 of these. So that would give me the 7,000. Then we have 4,000. So that's represented with the lotus plant, which looks something like this. So I'm going to need 4 of these. And then we have 500, and that's represented with this symbol. So I'm going to need 5 of these. And then I have 0 for the tens and 0 for the ones. So my answer is going to be this. Okay, second question, write the Egyptian numeral as a Hindu Arabic numeral. So here I have a lotus plant. So I have 1, 2, 3, 4, 5, 6, 7. So that's 7, and they're each 1,000. So that's going to be 7,000. Then I have these squirrels, which are 1, 2, 3, 4, and each of these represent 100. So I'm going to have 400. Then I have 1, 2, 3, 4, 5 of these, and these represent 10. So 5 times 10 is 50. Then I have 1, 2, 3, 4, 5, 6, and each one represents a 1. So if we add these together, then we end up with 7,456. Write the Roman numeral as a Hindu Arabic numeral. So here you kind of want to go from left to right. The first letter here is C, that represents 100. The second letter is L, which represents 50. And then each of these X's are 10. And then we have the I's, which are representing 1, so there's 2 of them. So if we add all these together, then we end up with 100, 50, 60, 70, 80, and then the 2 from the I's. So my answer here is going to be 182. Now we go to the next one. Notice the line on top of some of the letters here. So the line means to multiply whatever's beneath it by 1,000. So if you notice here, I have a X, which is 10. And then I have I followed by a V. Since I has a smaller value than V, then for this, we're subtracting 5 minus 1, which is 4. So together we have 10 plus 4 is 14, but that has a bar, so I'm going to multiply that by 1,000. Then I have 2 C's, so that's going to be 100 for each one. So that's going to be 200. Then I have an X followed by a C. Well, the X is smaller value than the C. So for this part, I'm going to take 100 minus the X, which is 10. So that gives me 90. So then we have an I followed by a V. So this represents 5 minus 1, which is 4. So we're going to add 4. So now we do 14 times 1,000. So that's going to be 14,000 plus 200 plus 90 plus 4. And if we add all of it together, then we end up with 14,294. Now we want to write the number as a Roman numeral. So here I have 700 plus 40 plus 1. So if I write it in expanded form, it may make it easier to see. So for 700, I know I can write the letter D, which represents 500. Then I'm going to need another 100 and another 100. So 500 plus 100 plus 100 gives me the 700. And then 40, I can write it as L represents 50, but I need it to be 40, so I can subtract 10. So I'm going to write the X in front of the L to represent that subtraction. Then we have a 1 that's represented with I. Write the Hindu Arabic numeral as a Roman numeral. So here I have a 4,745. So for the number 4, I can write it as IV. So that would be 4, and I need to multiply it by 1,000. So I'm going to write my bar on top. Then 700 is DCC. That's 5, 6, 700. 40, as we saw earlier, is XL. So that's 50 minus 10 is 40. And then 5. Write the numeral in its expanded form. So here the 5 is representing the ones place. So that's going to go on the far right. And then the 0 represents the tens place. And then 4 is representing the 100s place. And then we have a 0 and a 7. So anytime you see 10 to the 0, that just means 1. Simplify the expression. So here 10 to the 0 is the same as 8 times 1. 0 times 10 to the first is 0. Here we get 6 times 10 squared. 10 squared is 100. And then we get 5 times 10 cubed, which is 1,000. And 7 times 10 to the fourth, which is 10,000. So 7 times 10,000 is 70,000 plus 5,000 plus 600 plus 0 plus 8. So if we put this together, we get 75,608. Okay, the next question, write the Babylonian numeral as a Hindu Arabic number. So here we want to group these together first, and there's 9 of them. So this is 9 times the ones place plus, notice there's a gap here. So this symbol represents 10, and this represents 10, these represent 1. So that would be 12 times the next place value, which is going to be 60, because we're in base 60, plus here I have these together, so that's 1, 2, 3, 4, 5 times the next place value, which is 60 squared. And then finally, this is by itself. There's a gap here. So that's going to be 10 times 60 cubed. 60 cubed is 216,000 times 10 is going to give us 2,160,000. 60 squared is 3,600 times 5 is going to give us 18,000. And 60 times 12 is going to be 720 plus 9. So if we put all this together, we end up with 2,178,729. Write the Hindu Arabic numeral as a Babylonian numeral. So here my recommendation is to write the place value first. So we have 160, 60 squared since we're in base 60, 60 cubed, and so on. So this is 160, 60 squared is 3,600, and 60 cubed is 216,000. So we take our number, 10,654, and we divide by the smallest number that will go into it, or the biggest number that will go into it, which is 3,600. So 10,654 divided by 3,600 is going to go in twice. So 3,600 times 2 is 7,200. So we subtract, we get 4, 5, 4, and 3. So then we take this remainder, 3454, and we divide it by the next place value. So we already used 3600, so the next one is 60. So we're going to say 3454 divided by 60 is 57. And 57 times 60 is 3420. So we end up with 34. So now we take the remainder and we divide by the next place value, which is 1. So that goes in 34 times, and we end up with remainder 0. So the numbers that we get up here, this is what we need to represent using the symbols for the Babylonians. So 34 can be written as 10, 20, 30, 31, 32, 33, 34. Now I'm going to leave a space here. 57 can be written as 10, 20, 30, 40, 50. And then we need 7 of these. And then I'm going to leave a space and I'm going to represent 2. And so this would be your answer. Write the Mayan numeral as a Hindu Arabic numeral. So for the Mayans, remember the place value is 1, 20, 18 times 20, 18 times 20 squared, and so on. So the first level here, we have 5, 10, 11, 12, 13. So we would multiply 13 times 1. The next level is 2 times 20. So we're in the 20th place. And then this symbol represents 0 times the next place value, 18 times 20. And then last we have a 5 times 18 times 20 squared. Okay, so 13 times 1 is 13. 2 times 20 is 40. 0 times 18 times 20 is 0. And the next one we have 20 squared times 18 times 5 is 36,000. So if we add these together, we get 36,000 plus 0 plus 40 plus 13. So 36,053. Okay, the next one. Now we want to write it as a Mayan. So first we're going to write the place value 1, 20, 18 times 20, 18 times 20 squared, and so on. So this is 1, 20, 18 times 20 is actually 360. So I can write 360. And 20 squared times 18 is 7,200. And this keeps going on forever. So here we take our number, which is 196, and we're going to divide by the first place value that will go into it. So that would be 20. So 196 divided by 20 is going to be 9. It's going to be, goes in 9 times 20. So we get 16. So then we take our 16 divided by the next place value, which is 1, and we end up with 0. So we're going to represent our Mayan number using these numbers here. So first we represent 16. So that's 5, 10, 15, 16. And then 9 would be 5, 6, 7, 8, 9. Notice I left a little gap here. So this would be our answer. Convert the given numeral to base 10. So here, since you're in base 6, we're working with 1, 6, 6 squared, 6 cubed, 6 to the 4th, and so on. So 24 or 2413 base 6, we can write it in expanded form. So we would have 3 times 1 plus 1 times 6 plus 4 times 6 squared and then 2 times 6 cubed. Now we can simplify, so 6 cubed is 216 times 2 is 432 plus 6 squared is 36 times 4 is 144. 6 times 1 is 6. 3 times 1 is 3. If we add this, we get 432 plus 144 plus 6 plus 3 is 585. Okay, the next one, convert the given base 10 numeral to the indicated base. So now we want to go from base 10 to base 8. So the important thing here is to recognize we're going to base 8, and I can write this place values as 1, 8, 8 squared, 8 cubed, 8 to the 4th, and that's going to go on forever. So we want to make sure that we know what these are. So 8 squared is 64. 8 cubed is 512, and so on. So we take our number 403 and we're going to divide by the first number that will go into it, which is 64. So 403 divided by 64 goes in 6 times, and 64 times 6 is 384. So if we subtract 403 minus 384, we end up with 19. So now we take the 19 and we divide by the next place value, which is 8. So 8 goes into 19 twice. So we get 16, remainder of 3. And now we take that remainder and divide by the next place value, which is 1. So we end up with 0. So our number here is going to be 623, and we're in base 8. So you can either write a small little 8 or you can write the word 8. Find the sum in the same base as the addendums. Okay, so here we want to add 1, 1, 1, 0. This is 2, base 2, plus 1, 0, 1, base 2. So I like to write them in this way. So we have 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 2. But since we're in base 2, we cannot use the digit 2. So 1 plus 1 gives me 2. So we have to convert that. So you take your number 2, and I can divide it by 2. And so we end up with 1, 0. Okay, so the number 2 represents 1, 0. So we're going to have 1 plus 1 is 1, 0. So I write the 0 down and I carry the 1. And then 1 plus 1 is 2 again, but we know that 2 is the same as 1, 0. And so then our answer is 1, 0, 0, 1, 1. Find the difference. So we're going to write the numbers in this way. So 0, 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 1 is 0. And 1 minus 0 is 1. Okay, let's multiply. So here we have 7, 3, 5, 4 in base 8 times 6 base 8. Since we're in base 8, remember that the only digits you can use are 0, 1, 2, 3, 4, 5, 6, 7. And so here 4 times 6 is 24. Let's figure out what these place values are. So we get a squared is 64 and 8 cubed is 512. Okay, so 6 times 4 is 24. So the biggest number that will go into 24 is 8. So that goes in 3 times. And then we take our 0 and divide by 1. So 6 times 4 is 24, but when you convert 24 to base 8, we get 30. So we write down the 0, carry the 3. So now we say 6 times 5 is 30, plus 3 is 33. So here for 33, we can use 8 again. So 8 is going to go into 33 4 times, so we get 32. So that's remainder of 1. So we take our remainder, divide it by 1. So we get 0. So 33 converted to base 8 is 4, 1. So we write down the 1, carry the 4. 6 times 3 is 18, plus 4 is 22. So again, we can divide by 8. That's going to go in twice, so that's 16. 22 minus 16 is 6, so we can divide that by 1. So here our answer 22 is, when converted to base 8, is 6. So we write the 6, carry the 2. 7 times 6 is 42, plus 2 is 44. So we divide by 8 again. So 8 times 5 would give me 40. Remainder of 4, so we divide by 1. So 44 converted to base 8 is 54. And so our answer here is 54610 in base 8. Find the quotient and remainder for 10024 divided by 12, 4. So here what I like to do is multiply 12 times 1, 4 is 12. 12, 4 times 2, 4. So 12, 4 times 2, 4. 2 times 2 is 4, so that's 0. Carry the 1, so 2, 3. So we get 30. 12, 4 times 3, 4. 3. Okay, so 12, 4 times 3, 4. 3 times 2 is 6. If we convert that, we would divide by 4. We get a 2. So we get 1, 2. So I write down the 2, carry the 1. 3 times 1 is 3, plus 1 is 4. 4 converted into base 4 is going to be 10, or 1, 0. Okay, so here if we look at what we have 100, so 12, 4 goes into 100. If we use 3, that's too big, so we would use 2. And 12, let me erase this. So 12, 4 times 2, 4 is 30. So we're subtracting, that's 0. That's going to be 0, but we're carrying over 4 since we're in base 4. 4 minus 3 is 1. Bring down the 2. And then we have 102, which is 3. So our answer is 234. Determine the units digits. So here we have 4 to the 800. So one way you can do this is we need to figure out if there's a pattern. So 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. 4 to the fourth is 256. 4 to the fifth is 10, 24. So you should start seeing a pattern here. 4 to the 6 is 40, 96, and so on. So it wants to know the units digit. That means the ones digit. So this to the 800 and this to the 800 power, that would be too big to put in a calculator. But if you notice here, when 4 to the first power gave me a 4, 4 squared gave me a 16. So in the ones unit, we have a 6. 4 cubed gave me 64. The ones unit was a 4. 4 to the fourth was a 6 in my ones unit. 4 to the fifth was a 4. 4 to the sixth was a 6. So in the ones unit, you're alternating. It's either a 4 or a 6. So 4 to the seventh is going to be some number, but because of the pattern, I know it's going to end in a 4. So 4 to the seventh is going to be 16,384. And so I was right about this, right? So 4 to the eighth is going to give you some number that ends with 6. So that number is 65,536. Okay. So now we got to figure out when does it end with the 6 and when does it end with the 4. So if you notice here, anytime that the power is an even number, then it's ending with the 6. So what you want to ask yourself is 800 even or is it odd? So 800 is even. So that means that this number is going to end in a 6. So my answer would be 6. Okay, the next problem is a word problem. So it says a frog is at the bottom of a 19-foot well. Each time the frog leaps, it moves up 3 feet. If the frog has not reached the top, then the frog slides back 1 foot before it's ready to make another leap. How many leaps will the frog need to escape the well? So here for this problem, you can draw. Okay, so I have a well here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So the frog starts here and it's going to go up 3 spaces. 1, 2, 3. And then it's going to come back down. So that's 1. 1, 2, 3. And it's going to come back down. That's 2. 1, 2, 3. It's going to come back down. That's 3. 1, 2, 3. It's going to come back down. That's 4. 1, 2, 3. It comes back down. That's 5. 1, 2, 3. It comes back down. That's 6. 1, 2, 3. It comes back down. That's 7. 1, 2, 3. It comes back down. That's 8. 1, 2, 3. So it gets to the top. It doesn't have to come back down. So that was the last hop. And so we're going to have 9 leaps. A shirt and a tie together cost $59. So you have a shirt plus a tie, and that's going to give you $59, or it's going to cost you $59. The shirt costs 25 more than the tie. So here the shirt is $25 more, so that's addition, than the tie. So we can, instead of S, we can write it as 25 plus the tie, and then this is still the tie over here. So if we combine the equation here, we have one tie, so that's going to give you 2 ties or 2 t's. And then we can subtract 25. So we end up with 2t is equal to 34. Divide by 2. So t is equal to 17. So that's how much a tie costs. So your shirt, you can either put the 17 in for t here or for t here. So the shirt we know is 25 plus the 17. So 25 plus 17 is going to be $42 for the shirt. Okay, the next one, the number of ducks and pigs totals 44. So here, one way you can do it is just draw 44 circles. So that's 40, 41, 42, 43, 44. Then we know that together they have 122 legs. So assuming each duck has 2 legs and each pig has 4, how many of each animal do you have? So we can draw legs in all these circles. And I'm drawing 2 because I know that each animal at least has 2 legs. So if we do this, then we're going to have 2 legs on all these circles. So that's 44 times 2 is 88. And altogether, we should have 122 legs. So we're missing, if we subtract 122 minus 88, we're missing 34 legs. So we can come in here at 34 more legs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So now I can see that I'm going to have 11, 12, 13, 14, 15, 16, 17 pigs, and then the rest are ducks, which is 27. How many ways can you make change for 25 cents using dimes, nickels, and or pennies? So we can draw a little chart, dimes, nickels, and pennies. And we want to see 25 cents. So we cannot have 3 dimes, that would be too many. So I would need 2 dimes, so that's 20. I can have 1 nickel, so that would be 25 cents. Or I can have 2 dimes, 0 nickels, and 5 pennies. And that would be my only combination there. I can have 1 dime, so I'm going to just keep going down. And then I can have 3 nickels, and that would give me 25 cents. So I would have 0 pennies. And then I can have 1 dime. I could have 2 nickels, and I would need 5 pennies. Or I can have one dime, 1 nickel, so that's 10, 15, and I would need 10 pennies. Or I could have 1 dime, 0 nickels, and I would need 15 pennies. Or I could have 0 dimes, 5 nickels, 0 pennies. I could have 4 nickels, 5 pennies. I could have 0 nickels, 0 dimes, 3 nickels, 10 pennies, or 0 dimes, 2 nickels. So 2 nickels, that's 10 cents. So I'm missing 15 pennies, or 0, 1. So I would need 20 pennies, or 0, 0, 25. And so these are all my combinations, which I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 ways to make change. The next one, if 10 people greet each other at a meeting by shaking hands with one another, how many handshakes take place? So you have one person and there's 9 other people. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So if this person shakes hands with all of these people, then how many hands did he shake? So this person shakes hands with this people. So that's 9 handshakes. And then this one shakes hands with the other 9 people. So that's 9 handshakes. This one does the same. So that's 9. 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 9, 9, 9, and 9. So there's 9. There's 10 nines. So if we add these together, we get 90. However, when this guy shakes hands with everybody, then notice that this guy already shook hands with this one. So we cannot repeat it. So we can take half of these handshakes, which would be 45. Okay, so another way you can do it is we can say there's 10 people and each person's going to shake hands with 9. So 10 times 9 is 90. And then we divide by 2 so that we don't get the repeated, which is 45.